I want to talk about how you can work with an IoT sensors, or you can work with motors, you can work with displays, especially if they're I2C, sometimes if they're SPI, depending on the board you're using, but like individual I/O pins. This particular example I'm going to give you doesn't have any pulse width modulation, so you can't do dimming and that kind of stuff, but there are boards that do that. And what I really want to say is you can do this on your PC. This is like really cool. You don't have to write any microcontroller code. You can write Python code using the same libraries that would you write on the microcontroller. You could test them on your PC, and then potentially you can download them to your device with very few or if any changes. So what I want to talk about real quick, just show you how this will be hooked up. We have a PC. In this case, it's got an Adafruit MCP2221 breakout board. This is a USB to I/O board converter, and basically you can plug. It's got like maybe 8 I/O pins on it, and so you can hook up different things. I've hooked up servos to it. No, not servos. It's the one thing you can't do pulse width modulation. But I have hooked up air sensors, a gyroscope, and in this case, an I2C backpack. I2C connected LCD. This is one of those 16 by 2 displays. They come in a bunch of different sizes. I have another video I did, which is like a $5 display. This one I pulled off of a Raspberry Pi that I'm not using anymore. And it turns out it's actually an I2C display for the Raspberry Pi to save pins. And so you may have a 3.3 volt floating around, and you can just pull it over, right? So in this case, there's also an FTD board that Adafruit has that works with this. This one was cheaper, or maybe it wasn't available at Microsoft. Anyway, so what we're going to do is we're just going to run regular Python 3 on a PC, and we just run this thing called Blinka, and it is basically the Python library for Adafruit that runs on any PC or on a Linux computer, right? Like a Raspberry Pi. And then I'm going to tell it that it's the fake microcontroller board we're running is the MCP2221. And in that case, the driver for that board, or whatever the home board code is for that, it knows it's going to talk to it over USB, and we can go and find that board. And then I'm going to use a regular Adafruit LCD driver for this that happened. If I was running on like a Pico or something else, it would be the exact same driver. In fact, none of this code is going to be different if I were to run this like on a ESP32. Well, you can't run MicroPython on those, but any of the boards that you can run, CircuitPython on. If this was MicroPython, I probably could, but this is CircuitPython I'm using because those folks did a great job with this adapter. I'm like blown away. The code I'm going to use is going to be from my Circuit Playground, and you can see I've got a couple here. One where I played with an old school accelerometer. No, it was a rotation sensor. And I actually bought a new one because I ended up having to write my own or hack up the driver for this, which was a little embarrassing. Yeah, I took the Adafruit L3G20 driver and I changed one line of code in it, and that let me use my really old accelerometer and or whatever it was. Yeah, gyroscope. Sorry, and also I could test it on my PC. So the two I got is the 16 by 2 backpack from Adafruit and this really old gyroscopy thing. So let me just pull this up. The code for this is pretty much standard Adafruit Python code. You basically just pip install. You get to pip install it because you're running it on your PC. You set an environment variable so it knows which environment it's going to run in. And there's a couple. There's the FTD one, this one. I think there's a few others. I'm probably going to go out and look. I actually wish they could do it for a couple other things. But I do not know how to write another board driver, so it doesn't matter. So anyway, that's all I wanted to show you. No, I'm not going to use the screen reader for this. So what I think I'm going to try here is just give you a feel for how this works. So I'm sitting, you know what, let's do this. Oh, come on, Joe. Okay, so I'm not just sitting in a shell, PowerShell. This will work on a Linux machine too. I'm just going to run Python 3, right? So here I am in the REPL, and what I can do is this board does no modules in it. It's really not set up for this, the Python code, but what we're just going to go import MCP2221 and LCD 16x2.py. Oh, no, not that. PY. And we're going to make this go away, and we're going to make this bigger and scroll down. And then I'm just going to import it and hit enter. So that's it, enumerating all of the interfaces on the USB bus, because that's in my program. It's now connected to the device. That took 3 seconds. This one in particular takes a little while. You can see it's actually running through the code now. It drew hello, and now it's going to say goodbye, and then it's going to turn off the backlight. And that's it. So pretty straightforward. Oh, and then it's reading the buttons, because this one's got buttons on the shield. And so you can actually write Python code and hit the buttons, and it'll actually, and then that same code will work when you run it down to the microcontroller. And that's it. That's what I wanted to show you, was really the ability to run IoT, I2C, and other connected GPIO devices with a simple breakout board and run it on your PC. And I think this is an example of how it was hooked up on this board. This was a Python Raspberry Pi Shield, and you can see the little board super tiny in the back. This thing is really cool. And this is the hookup I did for it. I only used the I2C lines, a 5 volt and ground, and that's because this old Pi plate actually expected 5 volts, and there's 2 5 volt connectors here, but it had to be on this one. And that's it. It is really cool. You can, the board, I don't know if you could see it in the, maybe you can just barely see it at the top of the screen. This one's actually got an accelerometer on it too, so if I pick it up and spin it around, I can get the different angular momentum or radians per second off of that. Also, so you can actually hook up multiple to this device, because you can hang them off this bus, and then you've also got some other pins, or you could hook it up to a compass or a GPS kind of thing. Anyway, it's pretty cool. And then the code for this is the sample I showed up here. It was this file. So go this, if you want to teach somebody how to write blinky lights code or servo, well, this particular one, you got to get the FTD instead of this one, but you want to have it do something else, light up a display, run a servo, or something else, then you could do that all from your PC without writing a code in the microcontroller. To be honest, like 70% of the stuff I've done on IoT devices, I could probably do with this, except for the pulse width modulation. But that actually would be really easy, because this is a, because of the fact that this is, this device here actually has I2C on it. It turns out I can hook up a pulse width modulated adapter to that, and then I could hang all my LEDs and other stuff on it. I could do servos that way. I just can't on this particular one hook it up direct. But it's super cool. Adafruit does amazing work with this CircuitPython, and it is fun to play with.